how do we measure how unusual points in a data set are, even if the data sets represent totally different quantities? We compute what's known as a z-score, the value of the point from the data set minus the mean divided by the standard deviation. Recall from the normal random variable, 95% of the time you're within 2 standard deviations of the mean. You can see that with the norm disk function. 7% of the time you're within 3 standard deviations of the mean. And computing this quantity, anytime it's greater than +2 or -2, we call it an outlier or unusual data point. So some examples. IQs have a mean of 100, standard deviation of 15. If your IQ is 130, you're 2 standard deviations above average. That would be your z-score. SATs used to have a mean of 500, standard deviation of 100. So a 700 SAT would be 2 standard deviations above average. So basically a 700 SAT and a 130 IQ are sort of above average to the same degree, even though the SAT is 200 points above average and the IQ is 30 points above average. Okay, so what we want to do now is compute the z-score for NFL quarterback statistics, and then we'll look at the stock market. So we have the following statistics for Peyton Manning's last great year, 2013. Quarterback rating, the bigger that is, the better the quarterback supposedly. Completions, how many passes did his receivers catch? Attempts, how many passes thrown? Completions divided by attempts is percentage. Yards are how many yards gained passing. Yards per game are yards divided by games. Yards per attempt would be yards divided by attempts. Touchdowns are touchdown passes. Interceptions are balls caught by the other team. The only thing that's bad here is a lot of interceptions. So let's get the mean and standard deviation, compute the z-score according to this formula right here. And then we can use conditional formatting to highlight the outliers, and then we'll talk about the worst days in stock market history. Because you wouldn't expect, since 99.7% of the time in normal random variables within 3 standard deviations of the mean, you wouldn't expect very often to see values more than 3 standard deviations away from the mean of something followed a normal random variable. So when we look at stock market returns, we'll see it's fairly common for a daily stock market return to be more than 3 standard deviations from the mean, and that sort of indicates stock market returns don't follow a normal random variable, which is important in finance. Okay, so we first need the mean for each of these statistics, but that's simple. We use the average function. Control Shift down arrow, one of our favorite things, like in Sound of Music. And then we would do the standard deviation. Right there. Now to get the quarterback rating z-score, we would take the actual quarterback rating of 115 minus the mean. We need to $sign that 2 because we don't want the 2 to change. When we copy it down, the 2 has to stay still, but the B can change to a C. We divide by the standard deviation. The 3 must stay still. So 115 minus 82 is 33 divided by 16. That should be about a +2. Okay, now we drag that across and we can copy that down. Okay, now we want to format this. So we want to say if the absolute value, in other words, if the number itself is greater than +2 or less than -2, it should be highlighted. Home, conditional formatting, new rule, use a formula. Now when I did this last time, it put quotes in, which screwed it up, but I want the absolute value of K5 greater than 2, because that'll copy across. It'll try every cell in this range, and if it's greater than +2 or less than -2, it should be highlighted. So I can say format, I can say orange, and I can click OK. Okay, there we go. So Peyton Manning is an outlier in a good way on 4 statistics: quarterback rating, yards, yards per game, and touchdown passes. Drew Brees is an outlier on 2 good statistics. Now, being an outlier in interceptions is really bad. Carson Palmer, this is before he got really good with Arizona, and Joe Flacco, and Eli Manning had a terrible year because his offensive line was bad. He threw almost 3 standard deviations above average on interceptions. Okay, so that gives us a real clear way to see if somebody is near average. They'd have all numbers near 0 in these 6 columns. But you can see Peyton Manning's great year really stood out there. Now, what about the stock market? We click on the next sheet here. Okay. So now how do we get the z-score for the stock market? Well, the average return on a day, remember z-score is value minus average divided by standard deviation. Okay, now the daily standard deviation on the stock market is around 1.5%, although it goes up and down certain years. But the average return on a day is basically zero, because the market historically has gone up about 10% a year in 252 trading days. So I can just assume the average is zero. Now, here are the 10 worst days in stock market history. One in 1987, you might remember. Some in 2008, most of you remember. I don't think many of you probably remember 1929 or 1933. Okay. So if I would take the z-score would be the value minus the mean of 0 divided by 1.5 here percent. Okay, since we have these as percentages. So the z-score on these days is incredibly high. It's like -5 to -15. Now again, it's almost unheard of to get something that's 5 standard deviations different from average. I mean, that's like what they would call when they say 100-year flood or a 500-year flood, they're sort of using how many standard deviations away from average a data point is. And basically, you might have heard of Motorola's Six Sigma. Six Sigma is a very unusual event. Okay, we could actually maybe do a little video on Six Sigma. I think maybe I'll cook one of those up. But basically, we can see stock returns, daily stock returns, are probably not following a normal random variable, because we've got these 10 days which just shouldn't have happened if we have a normal random variable. And if I would list the worst 50 days, I mean, I'm sure they'd all be more than 3 standard deviations away from the mean, which shouldn't happen. So in summary, when you want to measure unusual something is, look at how many standard deviations above or below average it is. If it's more than 2 standard deviations above or below average, it's a very unusual data point.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching. And if you have any questions, just please let us know. Thanks.